Good day. You can see these are the electricity calculations formulas, and it's a massive list. Some of the stuff is old that you should know from before, and some of it is new, but you do not have to memorize. You will be provided with this. You should know that milli means 1/1000th. You should know kilo means 1,000, and mega means 1,000,000. Not very often do you have to go to from amps to milliamps, but you would multiply by 1,000. So in other words, I tell you the conversion, and next to it, it tells you what you do. More often, you have to go milliamps to amps, which means you take your milliamps and divide by 1,000. If we gave you kilovolts, for example, you would multiply by 1,000 to get volts. If I gave you volts, you would divide by 1,000 to get kilovolts. And the mega meaning million, here you multiply by 1,000,000, and going volts to megavolts, you divide by 1,000,000. So in other words, if you're going to bigger units, you divide, and if you're going to smaller units, you multiply. Now the PET formula, this was from the first section on energy, so this definitely should be review again. Those are your three formulas. Friendly reminder, if you're after energy in joules, then you need your power in watts and your time in seconds. And if you want your energy in kilowatt hours, your power has to be in kilowatts and your time has to be in hours. If you know your answer in joules and want to get to kilowatt hours, you're going to bigger units, therefore you divide by 3.6 million. And if you're going from kilowatt hours to joules, you multiply by 3.6 million. These are all conversions you should know from math for converting for time. This is our PIV formula, so P equals I times V, I equals P divided by V, and V equals P divided by I, and remember I stands for current. What this is saying is if a question gives you current and voltage and wants power, you use this formula. If you're asked for current and you're given power and voltage, you use that formula. And if you're after voltage, you use this formula if you're given power and current. Ohm's law is review from last year. This tells you how to find voltage, current, and resistance. The combining is a lot tougher, but not really. You can really short circuit things. So if you're after power and you're given current and resistance, use this formula. If you're after resistance and you're given power and current, use this formula. So these have all been rearranged. And if you're given the power and the resistance and you need the current, divide them and then take the square root. And similarly, we can do this if we're dealing with voltage, resistance, and power. And these are the three formulas we get. Efficiency goes back to the first section. And remember, when you write the efficiency in the last two formulas, divide by 100 so it's written out as a decimal. So hopefully that helps you. I think you may find these formulas easier than how I showed them in some of the notes. And with a bit of practice, you have to get good at reading a question. And I would suggest you underline each number and unit represented and identify it as power or current or voltage or energy or time, whatever it is. And then that will help steer you to what formula you're going to need to tackle the question.